Welcome to Tech Teach.
Multiple access protocols. So what is the meaning of multiple access protocols? We are having a sender and we are having a receiver and there is a channel. Okay, so what we do, once suppose us into a network, only a single sender is there and single receiver is there. If suppose this is the case, then they are connected with the link. So this link will be specifically for sender 1 and receiver 1. So only one sender is there, only one receiver is there. So this will be called a dedicated path. Dedicated path, that is basically for these sender and this receiver only. But suppose any network is there that is having large number of stations or large number of users. Okay, so if a single cable is there that is connecting everyone, it is like a bus type of structure is there into a network. If suppose this is the case, this is the single cable, that is a common cable, you can call it, or we can call it like shared. It is a shared one. So it is shared between these number of devices or these number of nodes, or we can call it these number of stations. So now in that case, if suppose this is the sender 1, sender 2, sender 3, sender 4, and suppose sender, or we can call it like a station 4, 5, 6, 7, 8. So anyone can send. Suppose this is sending, station number 5 is sending. If it is sending through this common shared path or common shared cable or the link, this will be whatever it is sending, the same will be going to each of the stations, remaining stations 1, 2, 3, 4, 6, 7, 8. They will also be receiving the same thing. Okay, and suppose at the same time 2 are sending. Okay, so if 2 are sending, whatever the packet is coming, suppose this is the packet sent by the 5, this is the packet sent by the 7. So whenever the packet will be coming in the same path, they may collide. So there is a possibility of collision. So if packet collide, in the sense once packet is in the form of bits, okay, so packet in the sense the data is there, that data is in the form of 0, 1, 0, 1, likewise 0, 1, 0, 1, whatever is the packet, okay, data. So these packets, when it will be colliding, it will lose its data or its value, whatever its value, that they may lose its value. So after collision, the data may lose, okay, or data may change. Okay, so either may change or may lose. So this is the case. More than one station is sending the data through a shared channel. Okay, so that's why to avoid these cases, there is a set of rules defined that will be basically identifying like when a particular station needs to send the data or when a another station can send the data and receive it. Likewise, there is a set of rules. So that set of rules are basically considered as the multiple access protocol. So instead of using like single dedicated path, if in a network multiple devices are connected, so they should be able to send and receive the data. So what set of rules are there that will be basically defining like how they can access the dedicated shared channel to send and receive the data, that is basically governed by the multiple access protocols. This is called the multiple access protocols. So its objective is to avoid collision, or data loss, to increase the efficiency. You can think in that way also. If efficiently a particular channel is being utilized, that means it is going to increase the efficiency. So this is multiple access protocol will be defining these parameters for a shared channel. This is basically comes under the data link layer itself. So in the data link layer, we have the data link control that we have just gone through. Then the next one is the multiple access resolution. So this is basically the role of data link layer itself. So under the multiple access protocol, it is divided into three different categories. The first one is random access protocols. Second one is called the controlled access protocol. And the third one is called the channelization protocols. Okay, so in our syllabus, basically only the random access protocol is given. So we will be only going through the random access protocols only. So under the random access protocols, we are having ALOHA, CSMA, CSMA CD, CSMA CA. So what is these protocols? Basically, we will be looking later on. So what is the basic idea of random access protocol and controlled access and channelization? We will just go through it. It is saying like it is random access in the sense all the stations, whatever in the random access protocols, whatever number of stations are connected into a network. So into a network, whatever the stations are there, they are having the similar priority or similar superiority over a channel. So suppose a channel is there, so they are connected. So it is not like any of the station is having a special privilege over this channel. This is not the case. It is random access. Here, each one is having same superiority. So in random access, we'll be having same, each station had same superiority. Means there will be no preference given to any station for using the shared channel. So here, when, so what basically happens is whenever we are sending a data, if the more than one stations are there sharing the same channel, there is a possibility of collision that we have already seen. So in the collision, the chances are like either the data lost or data is destroyed. Likewise, the possibilities are there. So that's why to remove that, there is first method, that is random access protocol. So here, whatever is the stations connected into a media, through a media, they will be having like the same priority. And also here, it will be like this will be helpful for avoiding the conflict. It will be avoiding the conflict based on the sending data. So once a station is sending data, so two stations or more than one station is sending the data. So how to avoid the conflict, that will be given by the random access protocols. So random access protocols, they will be basically focusing on different points. So what different points will be there, like they will be sending like when a particular station can access a media or a channel. So when a channel can be accessed, that will be governed by the random access protocols. They will be defining different set of rules to specify like which station can send or which station can access a particular media, or what can be sent. Okay, what to do when busy. Suppose the channel is busy at that time, what a station can do. These are basically defined, or how a station determine whether the transmission is failed or not, how to find out success of the data transmission or failure of data transmission. These are the points that are basically governed by some set of rules into the random access protocols. So that set of rules are basically called like ALOHA, CSMA, CSMA CD, and CSMA CA. So we will just see into the random access protocols. So here in random access or contention method or random access method, no station is superior to another station and none is assigned control over the other. In the sense, no one can control the other station and no one is having higher superiority. Control over others and superiority, they are main points. No station permits or does not permit another station to send. This is like no one can control the another. At each instance, a station that has sent data, that has data to send, uses a procedure defined by protocols to make a decision on whether or not to send. So that means if someone wants to send the data, based on the set of rules, they will be deciding whether that particular station can send the data or not. Okay, so that is the random access. So here the four types, that is ALOHA, CSMA, that is called carrier sense multiple access. The next one is the carrier sense multiple access. So it is CSMA, This one is CSMA CD with collision detection. Next one is carrier sense multiple access with collision avoidance. So it is CSMA with collision avoidance, CA. So these are the different types of random access protocols.